Hey guys, welcome back. Hope you guys are doing well. So today let's see the problem from problem of the day Geeks for Geeks, which is Coins of Geekland. So the question says that in a Geekland there is a grid of coins of size n into n. You have to find the maximum sum of coins in any subgrid of size k into k. Coins of the negative denomination are also possible at Geekland. So it seems like they are going to give us a grid of size k n into n, and we have to find out the maximum sum of any subgrid of size k into k, and we have to return that maximum sum, right? So okay, let's understand this question with an example. Let's consider a grid of size 6 into 6, and we have to find out a subgrid of size k, which is k into k, which is 3 into 3, such that its sum should be maximum. So okay, how can we approach this problem? So first we will go with the brute force solution, which is nothing but we are going to consider every subgrid of size k into k and find out its sum. And after getting all the sums, and we are going to pick up the maximum sum among all of them, and we are going to return it. So I hope you are getting. For this purpose, what is the time complexity if we approach this solution? So the time complexity will be around, like, so we are traversing the entire grid, right? Which will take n into n, and for each subgrid of every position, in order to find out the sum of all the elements inside that subgrid, we have to traverse that entire subgrid, right? For that purpose, we are going to consume extra k into k time. So in total, we are going to solve this brute force method in a n square into k square approach. But however, in constraints, they have given that k and n will be range up to 10 power 3. So this will not work anymore. It will throw us TL error, right? Okay. So what is the method more optimal solution? So they are expecting us to solve this problem in order of n square approach. So that means we have to solve this problem in n square approach. That means we have to find out the sum of every subgrid of size k into k in a constant time. This is what actually they mean. So we have to implement an solution that will find out the every subgrid of sum of every subgrid of size k into k in constant time. So okay, let's see how we are going to calculate. So for that purpose, I will need an extra matrix of size n into n, or else we are going to use the same matrix. So however, we should remember one fact, right? That whatever the data they are going to give us in a function, we should not modify it, right? So remember this one. So for that purpose, uh, I will consider a new array or a new matrix of size same, which is equal to n into n. And what is that new matrix represents? So I want that new matrix in such a way that every element, if we consider this element in that new matrix, so this should represent the sum of entire submatrix starting from here all over to the starting of the entire matrix. So I hope you are getting. I want the new matrix in such a way that every element inside that matrix. So if we consider any element, if we consider this element inside that matrix, this should represent the sum of the all the elements inside the submatrix, which is starting from here to all over to the starting of the entire matrix. So how we are going to get such type of matrix? This is nothing but, if you see this here, so in order to get the entire sum of this rectangle, so let's see if this 3 represents the sum of this first column, and this 3 represents the sum of this second column, suppose, and this 4 represents the sum of this third column. So in order to get the sum of this entire rectangle, simply we are going to get uh, all this entire row and we're storing it here, because this entire row, sum of this entire row represents the sum of every column, and if you add all of them and store it here, so this is nothing but the sum of this entire rectangle. I hope you are getting. So first what we are going to do, we are just copying this all the elements inside this original array to the new matrix, and then for each column we are going to perform such that every element inside a particular column should represent the sum of all the elements starting from that element up to the starting position of that column. And after performing all that, so for every row again I am going to perform such that if you are at this position, it should represent the sum of every element starting from there towards the starting of the entire row. So in this way we are going to get the new matrix such that every element represents the sum of entire matrix submatrix starting from here all over to the starting of the entire matrix. I hope you are getting. Okay, let's see how this new matrix is going to help us to find out the sum of every subgrid of size k into k in a constant time. Okay, let's see. So if we consider, if we want to find out, let's say, if we want to find out the subgrid of this subgrid of size 3 into 3, that means I want to find out the sum of all these elements inside this subgrid of size 3 into 3. So what is okay, here what is this 9 represents? This represents that it represents the sum of all the elements inside the submatrix starting from here to all over to the starting of the matrix, right? And in a similar way, what is this 5 represents? This represents the sum of all the elements inside the rectangle starting from here. Sorry. So this represents the sum of all the elements inside the submatrix starting from here towards the entire up to the starting of the matrix. And in a similar way, what does this 1 represents here? So this represents the sum of all the elements inside the submatrix starting from here all over to the starting of the entire matrix, right? So how can we get the sum of all the elements inside this green rectangle or inside this green matrix? This is nothing but 9 minus, so which is which represents the size of this entire submatrix, minus this is 5 which is the blue portion, and minus 1 which is present in red portion, and I have to include that part which is removed twice. So the sum of all these elements inside this part will be stored right here, right? So this is nothing but plus 3. So this value gives us the sum of the submatrix of size k into k, which is in green portion. I hope you are getting. Okay, let's jump right back into the code. So in order to do that, first I will consider a new matrix of size k of size n into n, right? And I will store every element of the original subgrid inside this new matrix. Now, in order to modify that array, in order to modify that matrix such that every element represents the sum of all the elements inside a rectangle, that is starting from here to all towards the starting of the entire matrix. So first, as we have discussed earlier, first we have to calculate every element such that it should represent the sum of all the elements up to the starting of that column. So for that purpose, is going like first I will consider every column, and for that column I will start from second element, and that element should represent sum of every element all the way up to the starting of that column. So this for does that. And what about rows? So we have to do similarly for the rows. So for that purpose, I will start from first row and start from second element in each row. So every element there should replace the sum of all the elements until up to the starting element. Now this will be like C minus. Now we got that new matrix, right? So all we have to do is we have to consider every submatrix, and we are going to find out the sum of all the elements inside that submatrix in a constant time and compare with our answer. And if it is great maximum, we are going to update our answer. Okay, first I will take answer as 0. So first subgrid of size k into k will be found at here, right? I is equal to k minus 1 is less than 1. So we are starting from here. So the first subgrid starts from here, right? So in order to find this one, I will start from here. So I will start from here, and in order to find out this sum of all the elements inside this subgrid, so what I will do, I should first consider this one, and I will subtract whatever the element present here, and I will subtract whatever the element present here, and I will add whatever the element that is present here. So if there are no elements or if they are out of bounds, then I will consider them as 0. So that means, so let's consider this as left, and this as top left, this as top. Left will be if how can you find that if it is out of bounds? Like if j minus k is less than 0, that means it is out of bounds. So I'll consider it as 0, or else new matrix of I of j minus k. I hope you are getting. So what about top? Top will be nothing but top is equal to. So in order to get it, if it is outside bounds or not, I will check like if I minus k is less than 0. Sorry, sir. Oh, if I minus k is less than 0, I will take as 0, or else we may take the I minus k or j. Similarly, in order to find out the element in a top left position, both I and j should be within bounds. So int left to top or top left is equal to. So if I minus k should be less than 0 or j minus k is less than 0, that means they are out of bounds. In this case I will take 0, or else new matrix of I minus k j minus k. So what is the answer? What is the sum? The sum is nothing but whatever the element whatever the value that we are currently at, we have to take minus of left minus top plus top left. This gives us the sum of subgrid of size k into k at current position, and if it is maximum, then our answer previously. So I was going to update it, and finally I will return the answer. Let's see if it works. It seems like it's working. Let's submit these. And yes, okay guys, we have successfully solved this problem in n square approach and with a space complexity of n square. And if you like this problem, please hit a like button, and see you later guys.